All right. Welcome to section 15.8, triple integral in spherical coordinate. Okay, first thing is that let's take a look at the spherical coordinate here. What is a spherical coordinate? So what is going on here? The angle theta is on the xy plane. Okay, so angle theta is on xy plane. The angle phi is from the z-axis on xy plane. X equal R cosine theta, y is equal R sine theta. This is the say phi, and then the p right there, it is not p though, they call it rho. Everybody see this plane right here? Okay, so what is so cool about this plane is rho right here is the radius of the sphere. Yeah. Well, pretty much we have that formula rho squared x squared plus y squared plus z squared. So the angle phi is from the positive z axis. So you can figure R. Right? So R is down here. Using what you learn in trigonometry or geometry, the angle phi and this angle phi, they are the same. This is very important. Say, look at this angle phi right here. And this angle phi, they are the same. So we have a plane, a rectangular plane. So how do you define the radius R? Rho psi phi, rho psi phi. Half of the plane is the right triangle. Cut off by the diagonal line. Of length rho is the right triangle. And inside the right triangle, we have R equal rho psi phi. And that is why you see that this is R right here. R. R. Well, how do we figure out Z? Z is also on the adjacent side. So Z is rho cosine phi. Similar to the previous section, we're just gonna do a few examples here so you can do the conversion back and forth. Example. Convert 0 to root 3 negative 2 to spherical coordinate. It's a good example. So in spherical coordinate, look at this picture here. We did the radius phi, the angle theta, the radius rho, the angle theta, and the angle phi. Need 3 of them. Okay. So the radius rho. Well, according to the formula here, rho is going to be root of x squared plus y squared plus z squared. Root of 0 squared plus 2 root 3 square plus minus 2 square, right? And this is going to be 4. Yeah, got one. The angle. So I usually do phi before theta, but you can do theta before phi, doesn't matter. So the angle phi, look at the angle phi here. If you look up here, you can figure it out. Use this formula to figure out, use the z. Phi is going to be all cosine of z over rho. Z is negative 2 over 4. The answer here is going to be 2 pi over 3. Yes, pay attention on here. Because the angle phi here, well, we define phi to be the angle from the positive z-axis, right? So phi can only go up to pi. Right? If it go to 90 degree, it get to the xy plane. If we go another 90 degree, it go all the way down there. Right? So phi here can only go up to pi. Yeah, not to 2 pi though. Yeah. So phi here is only go from 0 to pi. Just be careful with this one because you're gonna have to do the setup later on. Okay. Then we have to plot out the points, see if it match with the answer. Then it's all cosine of x over rho psi phi. And for the sake of this one, x over rho psi phi. Oh my God, look at the conversion. Oh, fortunately, x is 0. Well, it's pi 2. Plotted out in rectangular coordinate. X equal to 0, y is equal to 2 root 3. Yeah. And then z is going to be negative 2. So we got to go out down here. Right. -2 is going to be right here. And like parallel. Okay, so this is the point 0 to √3 minus 2. Okay, so the radius, right? This would be from here to here is rho, that's 4. The angle is right here, is this the angle theta. 2. And then the angle phi. Look at the angle phi here. It is more than pi over 2, right? It's 2 pi over 3, and that look correct. Here come another example. I'm going to do the conversion backward. Convert 2 pi over 4 pi over 3 to rectangular coordinate. Well, rectangular coordinate is x equal rho psi phi cosine theta. So it's 2 psi of pi over 3 cosine of pi over 4. Plug it in, you're going to get a √6/2. Right? Y is rho psi phi psi theta, because it's just all cosine theta or psi theta. 2 psi pi over 3 psi pi 4. It's the same thing. √6/2. Z is, oh man, I forgot the formula for Z already. Rho cosine phi 2 cosine of pi over 3. One. Okay. Now, √6/2 is bigger than 1. Okay, so y is √6/2. And then z is going to be 1. 1 is going to be somewhere right here. So that looks like it's go up by 1. Okay, so here come. It's 2. Okay, next step is we're going to get the angle theta. The angle theta is where you get the point right here. So I'm going to do this thing right. Actually, I wanted to use the same color here. Pi 4, just halfway through. And then the angle phi It's pi over 3, huh? It's above the xy plane. Right. Okay. Ooh. Surface description. Using spherical coordinate. Okay. First is gonna be example. Describe each surface. Okay, so you have a rho equals C. What is this one? Well, if we use the same trick, we know rho is the radius, so we know that C here is going to be a root x squared plus y squared plus z squared. So this is just a sphere of radius C. Okay. So here come B. Yeah, what happened if we have the angle theta to be some number C here? Okay, so theta equals C. Okay. Yeah, just a plane right here. It's not going to be the full plane though. This is just a half plane. Okay, so here come C. Well, what happened if we have phi equal to some number C? For C to be between 0 and pi over 2, you actually have this one. Remember the angle phi go from z-axis, right? So z-axis is gonna be a pi over C. So you have an angle C right here, and then this one is also going to be C. See? So if you see in all the direction, then what you have is just a cone, right? So you see this thing in all direction, you're just going to get a cone. Right? And then if you see this one, look at this. It's more than pi over 2. More than pi over 2, so you got to go all the way down here. You got to go below the xy plane. And then same thing here. below the xy plane. So if it's below the xy plane, and then you're gonna get this. Yeah, you're gonna get the cone the other way. Example. Describe z equal root of 3 x squared plus y squared using spherical coordinate. If you go this way to the spherical coordinate, is much better. Right. We know that x squared plus y squared, right? It's r squared. It's on the xy plane. So this one right here is the xy is on the xy plane. So it is okay to use polar coordinate because you can describe polar coordinate for any point on the xy plane. So what we have here is going to be a z equal root 3 r squared. So I mean root 3 r. And then the next step is the, well, you have to convert to a spherical coordinate. Right? Rho cosine phi root 3 rho sine phi. That's going to be a 1 over root 3 sine phi over cosine phi. So I mean this tangent, tangent phi is 1 over root 3, and then from there, can you give me the angle of phi here? Arctangent of 1 over root 3. Arctangent of 1 over root 3 is pi 6. Very good. Yep, babe. Oh, look at this thing here. Oh, it's just like what we have right here, right? So when phi is equal to an angle, and if that angle is between 0 and pi 2, I mean, between them not equal them, then we're gonna get a cone, right? This is exactly a cone here. Right? Z is equal to root 3 x squared plus y squared, right? That is the cone. I'm just gonna sketch it real quick using GeoGebra here. Come on. Root of 3 yeah, beautiful.